given a curve in the standard Cartesian plane, it's just x in terms of y rather than your normal y in terms of x. And we're asked to find the value of dy by dx at the origin. So that's going to be x equals 0, y equals 0. So for this, I'm first up going to find dx by dy. It's going to be much easier to differentiate rather than trying to get inverse sine of anything. And actually, to differentiate inverse sine, you essentially use this method, in fact. So now I just differentiate the right-hand side with respect to y. I use the chain rule. So differentiate sine gives cos, and then times by the derivative of the inside, that's 2. So I'm going to get 8 cos 2y. And that means I could either put the number in now for 0, 0, or I could find dy by dx. Let's do that. dy by dx is therefore going to be 1 over 8 cos 2y. So in this case, cos is just 0. It becomes 1 over 8 cos 0 rather. Let's just say that. And therefore, I'm going to get an answer of 1 over 8. Now I'll use a small angle approximation for sine 2y to find an equation linking x and y for points close to the origin. So this is given in the formula book for small angles. Sine x is approximately equal to x. There's actually an infinite expansion going on, but for small angles, they're not going to be relevant. So we just say it's approximately just x. And that means for small angles, sine 2y is going to be approximately 2y. Okay, because I've just replaced x by 2y. So x is therefore going to be approximately equal to 4 times 2y, which is 8y, and y is therefore going to be approximately equal to 1 over 8x. Explain the relationship between the answers to A and B part 1. Well, the gradient of y equals 1 over 8x is 1 over 8, which is the same as dy by dx at the origin. Basically, we're showing that it's consistent, that we're actually saying that for small angles, we have approximately a linear curve. It's going to have a gradient of 1 over 8, and yeah, the actual dy by dx is 1 over 8 at the origin, like they are the same, essentially. Last bit, show that for all points x, y lying on C, dy by dx can be written like this. What this is actually asking us to do is rewrite our dy by dx as 1 over 8 cos 2y in terms of x. Now remember, x is 4 sine 2y. I'll just write that here. And the key isn't actually going to be to try and straight away write y in terms of x or anything. It's to use trig identities to relate cos and sine. This is how we do it. So sine squared a plus cos squared a is identical to 1. So if I want to go from cos to sine, I can write that cos squared a is 1 minus sine squared a. So cos a is going to be the square root of 1 minus sine squared a. I'm going to ignore the negative here. This is known as taking the principal value, if I remember correctly. So that means that cos 2y is going to be the square root of 1 minus sine squared 2y. And we're ready to continue with this. So we're going to get 1 over 8 square root 1 minus sine squared 2y. Sine 2y is actually x over 4. And then when I square that, I'm going to get x squared over 16. Okay, remember, I'm trying to write it in this very specific way, so I'm going to need to, well, do I times by 16? Or no, because then I'd be changing the fraction, I could times top and bottom by something, but what I'm actually going to do is factorize out a 1 over 16 within the square root, which will give me 16 minus x squared. And then I can actually write it as 8 times the square root of 1 over 16 times the square root of 16 minus x squared. Square root of 1 over 16 is actually 1 over 4. If I times that by 8, I'll get 2. So my final answer is going to be 1 over 2 square root of 16 minus x squared. So quite a little technical question to finish. If you've never seen that before, that is going to be tough, but it's something to take away from this question. You can go from cos to sine using this kind of idea. You don't tend to do it that often, but it's there, and that's allowed us to write dy by dx in terms of x. It's going to actually finish by, this is where you maybe would have seen it if you've covered it. So y, if you want to integrate, or sorry, if you want to differentiate inverse sine of x, then you actually write x, you do exactly the same process, x equals sine y, and then dx by dy is cos y, which means dy by dx is 1 over cos x, 1 over cos y. But that's in terms of y. We really want it in terms of x, so we do exactly the same sort of process. Cos y is going to be the square root of 1 minus sine squared y, which in this case is going to be 1 minus x squared, and that gives us our answer. Dy by dx of y equals inverse sine, it's going to be 1 over square root 1 minus x squared. That's kind of what we're actually doing here. Okay, good. Well done on this question and on all the questions in the paper. Keep practicing.